for this quiz.
I've been ready.
The page 60s are out, so you just want me to print it whenever I get home.
Oh, I've got some extras down here.
Oh, perfect.
It's just my B day is behind because we haven't had any B days.
You want me more work?
Yes, I did.
Ooh, lemons.
That's what the L on your hat's for, right? Limits.
I don't know, man. We get the formulas, don't we?
Yes, they're already printed on the quiz.
Or if you're trying to memorize it like 2 minutes.
I mean, I've only said it 50,000 times.
I know.
If y'all want me to stop repeating myself this much. It doesn't hurt you to memorize them.
Yeah. Well, I had it mostly memorized. I was just like remembering. the
There's
last
nothing wrong with trying it and then double checking it.
Yeah.
Did not seem to catch a break over the weekend because of A-Push and all region practice. So I am very tired.
Hey, she's back.
You should think about that when you sign up for classes next year.
Well, all region is just,
Gotta pace yourself.
The schedule next year is kind of
I
weird.
guess. A-Push just takes forever.
Christian, so you're just saying something about the schedule?
Yeah. It's kind of weird.
Is it official?
Like,
I think it's official now.
Okay, I had
That's what they
seen.
said about protests, so.
Oh, they
that's right.
did? It's zero, it's no more 0 hour, no more 8th period.
okay, if you did not turn in the bookwork and the practice quiz, 59 and 60, this is your chance to get full credit on it. Make sure your name's on them and turn them into the box, please.
Supervisory is 50.
90-minute.
What do you think about the new schedule, Mr. Thompson?
10 more.
I love it. I think it's gonna be
Like
good.
it?
I mean, I wish we still had a 0 hour option,
Yeah.
but
I don't think that's a thing anymore, is it?
the biggest benefit that I think y'all don't consider is class times go from 80 minutes to 90 minutes,
Yeah.
which means that
Oh, wow.
your classes will be easier. You get an extra 10 minutes every time you meet. Less homework, more time to ask questions.
Nice.
That's a big deal.
My question is, do you
But
think
they'll be
they'll
even
keep it for
longer.
more than 1 year?
No way I'm gonna go through AB calculus,
Change it every year.
paying attention for an hour and a half. There's just no way.
Isn't this like their 5th schedule? In like
Yeah.
the past, like,
They're now
Half
gonna
decade.
have changed it every year since I've been here, and they changed it, like, for your sister, every year that she's been here too. So, yeah, it's like 5 years in a row they've changed it every year.
Oh, some of that was COVID, and that's not.
Yeah, that is true. But
Assuming you still need to get working get caught up. Okay, so you will need a calculator. You should number your quiz as 61. Notice the top half of the front page is all of the formulas, because you do not have to memorize them. Question 1 wants to know when to use each formula. And then questions 2, 3, 4, 5, and 6. Make sure you are paying attention to the directions there. It doesn't just want the answer, it also wants you to write out the formulas with the numbers plugged into them. So basically, what are you putting in the calculator to get that answer? So even if you feel comfortable enough that you could go straight to your calculator, get the answer out of your calculator, make sure that you're at least writing down that, which is what you should do for partial credit anyway. But if you read the directions, that's where half of your points come from. Half from the correct answer at the end, half from showing the formula with the numbers plugged in correctly. And in total, that makes just 32 points. So not a lot for an end quiz like this, but right now you guys don't have many grades, so I guess it will impact your grading grade book quite a bit up front. And finally, I do have 2 handouts I'd like you to pick up. They'll take probably less than 10 minutes for us to go over after the quiz. But the 2 handouts over here by your phones, please grab those when you're done. I don't know if you need to turn the homework or not, but make sure you do that before if you need to. No, you don't need to. Not for me.
get both of them. But that was the extra thing that you had to study on your own if you wanted to know how to do it.
Yeah.
Looks like we've got all of our quizzes turned in, So again, if you forgot the 2 handouts up by your phones, then I do need you to go grab those. Pretty short next lesson, but no sense in waiting. Let's go ahead and just take care of it. So again, we spent a total of 3 days on law of sines and law of cosines, simply for your sake and helping you recognize what you need to do should or when you see those on the ACT, unless you're just already happy with your ACT score and you don't need to study anymore, but that is a very common thing. So our next unit, we will spend, I don't know, a few weeks, so quite a while on limits. So today we're going to look at one of the easier question types, which is evaluating a limit from a graph or a table. And this is kind of important because it helps you see what we're trying to do when we try to evaluate a limit. It's just that moving forward, we don't normally have a graph, we don't normally have a table, so that's what makes this a little bit easier than some of the others would be, even though this is the same thing. Okay, so first off, there's really 3 ways to ask a limit question, so you probably should jot yourself down a couple quick little notes here. Okay, so of the 3, I'm just going to pick a number here. These currently read the limit of f of x as x approaches 3, but sometimes there's going to be a little negative sign that looks like a little exponent. When there is that, that means from the left. If there's a plus sign, that means from the right. And if there is not a symbol, a plus or a minus, this means both from the right and left. Okay, so even though none of the questions on this worksheet have this minus sign or this plus sign, strictly from the left or from the right, you still have to be able to do that in order to do limits on the right. Because limits without that symbol means that it has to be the same thing from the left and from the right. So what a limit is it is asking you what y value is the graph approaching as x gets closer to that number. So question number 1 here, we've got a graph of f, and it wants to know what is the limit as x approaches 3. Now again, you don't have to write this out for every single question, but I would like you to do it at least once for your notes here. We need to think about from the left, and we need to think about the right, from the right, before we try to answer this question. So from the left, now notice these are as x approaches 3, so this is the part of the graph I'm interested in only, the stuff I have highlighted. I don't really care about anything else. From the left, that means that you should pick an x value slightly smaller than 3 and get closer to 3. So as x gets closer to 3 from the left, the y value that it approaches, the y value that it gets closer to is -4. So that's the limit from the left. From the right, it's the same idea, except you got to come from the right. So you need to pick a number slightly bigger than 3. And as x gets closer to being 3, the y value approaches -4. And since it's approaching the same thing on the left and the right, we can say that the limit is -4. So the idea of the limit's not a super complex concept here. It's just what is the y value approaching? Not what's the y value there. I don't care about what the point is. I could care less what's happening at x equals 3. Just what is it approaching from the left and what is it approaching from the right? And if it's the same y value, then that's what your limit is. Okay, So, to say that again, in question 2, the limit as x approaches 5. So notice x equals 5 does not exist. There's a hole there, but that has nothing to do with limits. I do not care what's happening at x equals 5. I care what's happening as x approaches 5 from the left and the right. And since they're both approaching a y value of -2, that's what the limit would be. Okay, back up to number 3. The limit as h approaches 0. What do you guys think that might be? 2. I agree. From the left it gets closer to a y value of 2. To the right it gets closer to a y value of 2. Now notice down here, there's a point. When x is 0, y is -7. But again, that has nothing to do with limits. Limits are not points. Limits are just about what are you approaching as x gets close to that number. Could care less whether that point exists or where it is, whether it's right here or way up here or way down there. It's still approaching 2 from the left and the right. Okay, what about as x approaches -1? -3. Looks like it gets close to -3 on the left, close to -3 on the right. So the limit as x approaches -1 of that graph would be -3. That's what we are doing when we're trying to find a limit. We're describing the y value that it approaches. Okay, well, we can do the same thing with the table. Some people think tables are harder just because I guess you get less practice on them. It's less of a visual, but it should be the same process. If I want to think about the limit as x approaches -2 from the left, I would need to look at x value slightly less than -2, but get close to -2. This would be from the left. I also have to think about what it approaches as it approaches -2 from the right. So that's where you would pick an x value slightly bigger than -2 and then walk it back closer to being -2. And again, this is just an estimate because we don't know exactly what's going on. But what does it look like it's approaching from the left? Yeah, it looks like it's getting closer to a y value of 8. What about from the right? So 8 is a reasonable estimate. It looks like it's approaching 8 from the left and from the right. Again, there's no way to really know without having more points, but that's a reasonable estimate. Okay, I would like you to try the table on number 6, and then number 7 is a little trickier, but I'd like you to try it as well. So try 6 and 7, we'll check them, and then we'll go through the rest of the questions together. Unfortunately, I didn't scramble these questions up very good, so you'll see what I mean in a minute. But that's okay. This is just meant to be an introduction. I think I said this last week as well, but the reason why we choose to do a couple weeks of limits versus something else is just that if you ever do take calculus, whether that's next year in AB or in college, or maybe you think you're not going to take calculus, but in 5 years you decide to go to college or you change your major or something and you need calculus, all calculus classes always start off with limits. Calculus is really 3 big topics: integration, derivatives, and limits. And integration is just the opposite of derivatives, so you have to know derivatives before you can integrate. But derivatives only exist with limits. They're defined with limits. So if you don't know what a limit is or how to use them or how to find them, then you really don't know where a derivative's coming from. So all calculus classes always start off with limits. So like an advisory, you should be starting to sign up for some classes next year. It gives you a little bit of a taste of what the first couple weeks will be like in calculus. although we do it much more at a relaxed pace in here. But then it should also make it a little bit easier for you since you will have an idea of what a limit is and how to do most of it. So, okay, so I talked through that whole thing, but was that enough time for 6 and 7? Okay, so 6, as x approaches 1, it looks like from the left, it looks like the y values are getting closer to -6. From the right, it looks like they're getting closer to -6. So I would go with -6. We okay with that? The y value that it's approaching, not what the y value is at x equals 1. I don't even know that, nor do I care. Just what is it getting closer to? Okay, and then I said 7 is a little trickier. What y value does it approach as x approaches 4?
3 going to the left and 6 going
Okay,
to, or I mean, reverse.
so if you're talking about from the left, it's 3. If you're talking about from the right, it's 6. So are both of those the answer, or what? Remember, this is saying what y value is it approaching? Well, if it's approaching one thing on the left and a different thing on the right, this doesn't have an answer. We would say does not exist, D and E. The limit from the left has to be the limit from the right, or it does not exist. You can't have two numbers. Can't have two answers to this. So here's what I meant by I didn't scramble these questions up very much. But it looks like from the left it approaches 5. From the right it approaches -5. But as x approaches 0, it's approaching different things. So this limit does not exist. As x approaches 4 from the left, it looks like maybe -3. From the right, it looks like maybe +2. But if the limit from the left is not equal to the limit from the right, then this does not exist. The limit does not exist. Now, if it just said from the left, your answer would be -3. If it just said from the right, your answer would be 2. But because it doesn't have that, it has to be both. Okay, and then one more. As x approaches -5, again, so I'm only really interested in a little bit to the left of -5 and a little bit to the right of -5. The rest of this graph has nothing to do with this question. But it approaches 6 up here, -4 down here, not the same number. That limit does not exist. Okay, I would like you to try the last one because it does try to get you to work it backwards. It says for some x, for some value of x that it approaches, the limit would be 3. And there are a couple different answers that would be fine here, but I'd like you to try to find one before we talk about it together. Okay, so if we want the limit to be 3, x could be approaching what?
2.
Okay, 2 is one acceptable answer. From the left and from the right it approaches 3. Or how about
Something is a little less than negative.
right about here it's 3. So I don't know, a little bit more than 4. You have to estimate, we can't read it that closely. Or even one more. What would you estimate the last one to be?
8 or 2. Or negative 8.
Right, way over here at about negative, I don't know, 8.5, negative 8.2. I'm not that interested in the estimation. Just so you see that there's 3 different places where the limit is approaching a y value of 3. So any one of those would have a limit of 3. Okay, anything that jumps out at you about these question types before we put it away? Okay, the last thing I want to say, even though I know I just said it a couple times already, but this is the part that is difficult for some students. That just doesn't stick at first and makes them much harder than they need to be. And you may want to write this in words at the top of your page. Limits do not care whether that point exists, or if it does exist, whether it's way up here or not. Limits are strictly about what y value is it approaching. It could care less what's happening at that x value. If you try to treat it like what's happening at that x value, then you're treating it like a point. And that's not a limit. That's not a calculus topic. That's points are algebra topics. Now, in some ways, I said one more thing, but I lied. You did do limits. You just didn't use limit notation. Do you guys remember doing like in behavior and saying something like, as x goes forever to the right, y goes up? You remember saying in behavior like that? Well, in calculus, we say the exact same thing. We just use limit notation. As x goes to infinity of this function, it approaches a y value of infinity. But it's the exact same line of thought. Or as x goes forever to the left, the y value goes forever down. So just a different way to do in behavior. This isn't really a mathematical thing. They just let you get away with that in algebra because that's all you've seen. Okay, go ahead and number those handouts as 62. I would probably staple those together, but we will slowly build upon that each day. But again, what you really need to get out of that is, I mean, you'll probably see one on your test, evaluate a limit from a graph, probably one where we'll say evaluate a limit from a table. But more importantly is for you to see what we are even finding when we do limit questions, because we don't always have a graph to visualize it. Okay, that's all I've got for you today. You guys still have about 25 minutes, so if you have any schoolwork for another class, I would highly recommend that you do that.